Topic is based on the root polynomial. In this section we'll be seeing the product formula, which is a different type of root polynomial. So how we had seen the basic formula for the root polynomial, similarly you had seen the expansion formula, how you can solve using the expansion formula. Now we will be learning regarding the product formula. So the product formula is, suppose a board C is made up of two parts C1 and C2, where C1 and C2 have no squares in the same rows or column. Now for example, suppose a board, if this is a board, if it is made up of two parts, that is this square as well as this particular square. Okay, so in that two parts C1 and C2, where C1 and C2 have no squares in the same row or columns, same rows, or in the sense you don't have, these box doesn't come under this section as well as this column. So over here this should be blank, this should be blank, and here this should be blank and this should be blank. Even over for this particular column, this should be blank and this should be blank. So that is the definition in the first section. Suppose a board C is made up of two parts C1 and C2, where C1 and C2 have no squares in the same row or column of C. They don't have they don't have any square on this row as well as on this column, over here also as well as this column also. So then it is called, then such parts of C are called disjoint subboards of C. Then the root polynomial can be used, which needs nothing but the product formula, that is R of Cf. So what we'll do is, for one part we'll find R of C1 of x, which will again use the root polynomial basic formula, that is 1 plus R1 of x plus R2 of x square. Same formula. Over here also same formula. So product of these two will give you the R of C of x, that is of the main board. So for example, if you consider this particular board over here, this would be taken as C1 and this would be taken as C2. Entire root polynomial of this board is nothing but R of C of x, R of C comma x, that will give you R of C1 comma x into R of C2 comma x. So this gives the root polynomial for this particular board. So this is an example for the product formula. So let us see the problems based on this. So here we have two boxes, so which will be considering one box as C1 and other one we will take it as C2. So the example one is, find the root polynomial for the board shown below, shaded part. So first one, we'll take this as C1. So let us take the first shaded part as C1. It is, we'll just write those statements. We note that the given board C is made up of, the given board C is made up of two disjoint subboards, C1 and C2, where C1 is 2 cross 2, this board, okay, that is with numbered 1 2 3 4, with numbered 1 2 3 4, with numbered 1, 2, 3, 4, and second board, that is C2. Second board is the C2, numbered 5 to 11. Second board is C2, that is numbered 5 to 11. So this is regarding the two board. Now for that, first we have to find for the board C1. For the board C1, we have to find R of C1 of comma x. So within this 1 2 3 4, we know that R1 is equal to 4, R2 is equal to 2, because this and this is not there. So 1 4, combination is 1 4, and one more time when we take 2, this and this will be not there. So 2 3. So the R3 is 0. So the equation would be r of c1 of x comma x would be nothing but 1 plus 4x plus 2x square. Okay, for the board, this remaining board, for the board C2, R1 is equal to 1 2 3 4 5 6 7. Okay, R2 is equal to, what are the pairs? You just write down the statements what we have followed from the beginning. I'm not going to write the statements again. Okay, so I'll just write regarding the what are the values. You just write down the statements referring the previous example. So over here, when I take 5, this and this will be not considered. So the pairs possible, for 2 pairs possible is, I'll just write over here 2 pairs, 5 comma 8, 5 comma 9 and 5 comma 11. Okay, 5 comma 8, 5 comma 9 and 5 comma 11. 5 comma 8, 5 comma 9 and 5 comma 11. So 5 is done. Next we'll go to 6. When 6, it is, this section is not there. Okay, when it is 6, this column and this row is not there. So it will be combined with 6 7, 6 9, 6 10. 6 7, 6 9 and 6 10. Okay, so again you'll come to 7. When you come 7, this is not there. I'll just erase this section. When you come 7, this is not there and this is not there, and upper, however, it will not go. So 7 9 and 7 11 is the possible. 7 9 and 7 11 is the possible. Okay, 7 9 and 7 11 is the possible. When you come to 8, again this is not there and this is not there. So 8 9 and 8 10 is the possible. 8 9 and 8 10 is the possible. 8 9 and 8 10 is the possible. Rest, however, you know that 9 10 11 we are not going to consider. So 1 2 3 4 5 6 7 8 9 10. So R2 is 10. So just write down 2 pairs of the boards are 10. So R2 is R2 is 10. Now we have to find R3. R3 means 3 pair. So I'll just erase this. We'll take the red ink. R3. So 5, if I consider 5, this and this is not being combined. So 5 can be combined with 8. If you combine with 8, then again this is not there, this is not there. So 5 8 can be combined only with 9. So one pair of, for the R3 the pair is 5. For the R3 the pair is 5 8 9. One pair is 5 8 9. Come back over here. 5 8 9 was the one possibility. Next we came to 6. When it is 6, again this pair is not there. 6 can be combined with 7, only 7. Then when you combine with 7, this is not there. So left out is 6 7 9. So 6 7 9. So R3 value is 2. So for this, for R of C2 of x, the formula is 1 plus 7x plus 10x square plus 2x cube. So this is of the second rule. So 1 plus 7x plus 10x square plus 2x square. Therefore the product formula is R of C comma x is equal to R of C1 of x into R of C2 of x. So you had already seen this formula over here. R of C of x is equal to R of C1 of x into R of C2 of x. So just try to multiply and get it over there. So I'll write over here. So this is nothing but continuation is over here. Okay, so R of C of x would be C1 of x was 1 plus 4x plus 2x square into 1 plus 7x plus 10x square plus 2x cube. So this will result, you just try to multiply, this will result in 1. When you multiply 1 into this, it will be 1 plus 7x 1 plus 7x plus 10x square plus 2x cube. I just multiplied 1. Next, when I multiply 4x, it would be 4x into 1. All 4x into 7x would be 7 4s are 28x square. This into this, again this into this. So it would be 40x cube. Okay, and then again it would be 4 2s are 8 to the power x4. 8 to the power x to the power 4. So this I multiplied 1 plus, again 2x square is pending, so plus 2x square into 1, next again 2x square into 7x, so it would be 14x cube, plus 2x square into 10, that would be 20x to the power 4, plus 2 into 2, 4x to the power 5. Now write it again, reorder it and write it. So this would result in 1 plus, check for any 7x is there, 7x plus 4x, 7x plus 4x is 11x, okay, 1 plus 11x, 1 plus 11x, plus add the squares, 10x square plus 28x square plus 2x square, so that would result in 40x square plus 56x cube plus 28x to the power 4 plus 4x to the power 5. So this is how we are going to solve the root polynomial for using the product formula. So example 2, again find the root polynomial for the board shown below. So over here, for the root polynomial for the board shown below. So here we have the combination of all basic root polynomial as well as expansion formula as well as the product formula. So find the root polynomial for the board shown below. First let us mark the square number. Now we cannot apply product formula because over this we have a row column over here, and here also we have the column. We cannot split. So what we can do is we can first apply expansion, then we can apply the product formula. So first let us mark the square numbered 6. So let us mark this square. So I'll write here. First let us mark the square numbered 6, the square numbered 6 in the given board. C, this is the C, right? As star and obtain boards D and E, and obtain the boards D and E. Okay, D and E. So when I apply star over here, this section and this section will be deleted. Okay, so the D board will be just 1 3 1 3. When you apply star over here, this and this is deleted, that is D board, and just 5, that 5 is like 2 space here, just 5. So this is D, and E will be just elimination of this, so that would be, I'll draw away. That would be 1 2 3 4, and this has been deleted, and here attachment from here itself, seven 8 5. So this is E. So you got D and E. So from D you can see that R1 is equal to 3. Okay, R1 is equal to 3, and R2 can be paired only 1. So from this board we can write that from the board D. Okay, from the board D, R1, just consider this, R1 is equal to 3, R2 is equal to this and this pair, that's it. R2 is equal to, okay, just these two pairs, so that is 1, that is 1 comma 5, and R3 is 0. So the polynomial expression, that is R of D of x, would be 1 plus 3x plus x square, 1x square. This is 1, right? So it is 1x square. That is R of D of x in the board E. Now this is the board E. So again what we can do is, we want to apply the product rule itself over here. Okay, what we can do is again subdivide into E and D, again D and E. So let me do this in new page. Okay, So the E board, in the board E, that is previous, okay, in the board E, let us make the square, let us mark the square numbered phi as star, okay, phi as star, and obtain the boards D dash and E dash, D dash and D dash. So whatever this is there, now same board I'll be just drawing for you. That board was 1 2 3 4, 1 2 3 4, 1 2 3 4. So that would be 5 7 8. Now what we told is, let us mark the number phi as star. So when you mark phi as star, this will be deleted and this will be deleted, that is D dash. Okay, so that would be 1 2. Let us take it as, because already for the previous expansion itself we are applying again the expansion, so let us take this as D dash. So one gap, 1 2, and there is one column gap, and then you have 7, so that is D dash. Okay, so just taking phi, I would get 1 2 3 4 7 8, 1 2 3 4, and then directly 7 and 8. So this is E dash. Now for this D dash, you can directly find R of D dash, R of D dash of comma X. So this would give me R1 is 3 for, okay, for D dash board, R of D dash we have to find. So this would give me R1 is equal to 3. There are 3 items, and R2 will be the pair. Here however it is 1 7, it is not there in this column itself, so it is 1 7 2 7. R2 will be 2 because the pairs are 1 7 and 2 7. R3 is 0. So D dash formula would be R of D dash of X would be 1 plus R1 of X. R1 of X is 3X plus 2X square. So this is R of D dash of X. Now for board E dash, that is this board E dash, I can apply the product rule. Okay, so I'll write here, for the board E dash, since it is made of 2 disjoint sets, okay, so I can take C1, that is consisting of C1 as the first one, C1 as the first disjoint board, and C2 as, C1 as 2 cross 2 and C2 as 2 cross 1, that is 2 cross 1 column. Then the product formula applied to the board we can do, product formula. So first we have to find R of C1 of X. For that, if you want to find R of C1 of X, then it should be R of C1 of X. So R1 you have to find, this is taken as C1 and this is taken as C2. So R1 is 4, R2 will be just 1 4, one value, 1 4, I agree, yeah, 1, this and this is 1 4, just 1 4 as well as 2 3. R2 will be 2, R2 will be 2, so that is R2 will be 2. What are the pairs? 1 4 and 2 3. Okay, so for the C1 formula R of, so R of C1 X would be 1 plus 4x plus 2x square. Okay, so this is for C1. For C2, R1 is equal to 2. R1 is equal to 2. Yes, R1 is equal to 2. For C2, R1 is equal to 2 and R2 is 0. So the equation would be R of C2 of X. C2 of X would be 1 plus 2x. That's it. 1 plus 2x. So this is for the E dash, right? So E dash I applied product rule. So I'll just write over here. continuation is over here. Okay, r of e dash of comma x would be multiplication of this r of c1 of x into r of c2 of x, r of c2 of x. So that would result in 1 plus 4x plus 2x square into 1 plus 2x. So this would give me, first multiply all the ones, so it would be 1 plus 4x plus 2x square. I just multiplied all, again multiply 2 into this, 2x plus 4 2s are 8x square plus 4x cube. So combine this and form, it would be 1 plus 6x plus 10x square plus 4x cube. 6x plus 10x square plus 4x cube. So you got this result, that is r of e of x. Now what we have to go back and find e. We got what is e and we got what is d. Now we should apply for this expansion formula, that is for this expansion formula. So what we are supposed to do is, consequently the expansion formula applied to the board E else using you can write these, okay, that is, yeah, using this, let me name this equation as 1 and let me name this equation as 2, using else, using 1 and 2, then r of e of x, r of e comma x would be nothing but x into r of d dash of x plus r of e dash of x. Okay, and that would give me x into 1 plus 3x plus 2x square plus 1 plus 6x plus 10x plus 10x square plus 4x cube. So this, what I did is, for these two tables, I mean for this as well as this, I multiplied to find only this, okay. So this is the equation. For this I'll get the result as 1 plus 7x plus 13x square plus 6x cube. Finally, again I need to apply the expansion formula. Now I've calculated this. Finally, again for this and this I need to apply. So for that, d of x was this, and now whatever the new e of x you got, this will be like, let us name this as 3, okay, and then previous, using those 1 and 3, okay, whatever, first one and this one. So using final the expansion applied to the given board C. Finally, the expansion formula applied to the given board C, that is r of c comma x, it would be nothing but x into r of d comma x plus r of e comma x. So e comma x is this equation, x into r is what was there in the first we have solved, so that is x into 1 plus 3x plus x square plus r of ex should be 1 plus 7x plus 13x square plus 6x cube. So this would result in 1 plus 8x plus 16x square plus 7x cube. So this is the result of this problem. So this is the problem which involves normal root polynomial expansion as well as the product rule. So this is an example problem which covers all three concepts. So what was this is, first I put a star and I divided into D and E. This E, again I applied D and E. So there we got twice D dash and E dash. So we got twice we used expansion formula. Within this again I used the product rule. If you see over here, within this expansion, again I use the product rule for this particular table, and then I found C1 C2, I found it, and then again I used expansion and found this was again back to this expansion, then finally again I applied expansion to find entire board results. So this is regarding the example 2. Next concept is based on arrangement with the forbidden position. So over here what we are going to do is, suppose we have m objects, okay, like for example, if we wish to give, you will understand regarding what are these objects in the next example problem. If you want to give m objects, these m objects need to be arranged in n places. For example, if there are 5 students, like student 1, student 2, student 3, student 4 and student 5, and these student 1, 2, 3, 4, 5, they are given with m objects. Like some people might like orange, like imagine student 1 doesn't like orange, okay, rest people like, and like orange, apple as well as kiwi. Let us assume these are the fruits, and S2 and S3 doesn't like apple, whereas S5 and S6 doesn't like kiwi. So these are nothing but the objects. These are the objects that are to be arranged in n places, that is with the students, where n is always greater than or equal to m. That means n are these students. For them I am giving some objects which has to be arranged in certain positions, where certain conditions, where n is greater than or equal to m. Suppose there are constraints under which some objects cannot occupy certain places. That's what I told. Like student 1 doesn't like orange, so he cannot occupy that particular places. Whereas student 2 and student 3 doesn't like apple, so apple cannot occupy over there. Kiwi fruit also, S4 and S5, student 5 doesn't like it. Such places are called forbidden positions for the said objects. Such places are called forbidden positions for these such objects. Now within this, how can we arrange this? So by using this particular formula, n bar is equal to S0 minus S1 plus S2 minus S3. So S0 minus S1 plus S2 minus S3, so on till minus 1 to the power n Sn, where S0 is equal to n factorial. Now how many students are there? How many students are there? We have 5 students, so that is nothing but 5 factorial, where Sk is nothing but when the values of k is equal to 1 to 3 and so on till n, that would be 5 minus 1 into R1. R1 is what, when you, again this will be, for this you have to calculate the Rook polynomial. For this table you have to calculate the Rook polynomial, and you will get an Rook polynomial equation, how we have solved. So you can either solve it using expansion, either you can solve it with a normal Rook polynomial, or you can solve it using the product rule itself. You will get a huge equation. Like for example, if you see here, this is an equation, right? So from this you will get R1, R2 and R3. Why? X cube is there, x square, x. So same that concept itself, here we are going to use S1 and 5 minus 1k R1 into R1 till where? Here since we are only R3, till R3 we are going to find, and this using this equation. Here Rk is the coefficient of xk in the Rook polynomial, the board of m rows and n columns. So this formula is being used. So let us solve the problems based on this. Example 1, 5 teachers, that is T1, T2, T3, T4, T5 are to be made class teachers for 5 classes, C1, C2, C3, C4, C5. Okay, 5 teachers, T1, T2, T3, T4, T5 are to be made class teachers for 5 classes, C1, C2, C3, C4, C5. One teacher for each class. T1 and T2 do not wish to become class teacher of for C1 or C2. For C1 or C2. Now which will take it as n and which will take it as objects? So here you check. T1 and T2 do not wish to become class teachers for C1 or C2. T3 and T4 for C4 and C5, and same way T5 for C3 or C4 or C5. Okay, C3 or C4 or C5. Now we can take, for this we can take, consider the table as how many, 5 into 5 cross we have to do, right? So 5, 1 second, 5 into 5 cross. Okay, 5 into 5 cross. So just put a line. 1, 2, 3, 4 and 5. Here also 1, 2, 3, 4 and 5. So this is 5 cross 5 I have drawn. So 5 teachers T1, T2, T3, T4, T5 are to be made class teachers. So teachers are to be made class teachers for the 5 classes. So how many classes? 5 classes. So if these are to be made as class teachers for these classes, then all the teachers cannot be the classes. That means T1 can become class teacher of this. There are conditions. So these are actually objects, whereas the class teachers are taken as L. So we'll put C1 over here, C2 over here, C3 over here, C4 over here, C5 over here, and then T1 over here, T2 over here, T3 over here, T4 over here, T5 over here. Okay, we'll take T1, T2, T5, C1, C2, C3, C4, 5 are to be made class teachers for 5 classes. Okay, so this is the condition. 5 teachers are to be made class teachers for C1. 1 teacher for each class. 1 teacher for each class. So T1 and T2 do not wish to become class teacher for C1 or C2. So this T1 doesn't wish to become class teacher. T1 and T2, both the teachers, T1 and T2, they doesn't want to become class teacher of C1 and C2. So just break this rule. T1 and T2 both doesn't want to become class teacher. See, T1 and T2 do not wish to become class teacher for C1 or C2. So done. T3 and T4, T3 and T4 for C4 or C5. T3 and T4 for C4 or C5. That means even this teacher 3 and teacher 4 doesn't want to become class teacher of C4 and C5. That is T3 and T4, C4 and C5, they doesn't want to be a teacher. Whereas T5 for C3, C4, C5. C3, C4, C5. Okay, now this is the table. They doesn't want to. For the board, now see, whatever the shaded here, the situation can be represented by the board shown below, in which the rows represents these rows T1, T2, T3, T4, T5 represent the T, and the columns represents the teacher, okay, rows, and the columns represents the class teacher, I mean C1, C2, and the shaded squares together represent the forbidden placed. This is the forbidden placed. Now for this forbidden place, right, you have to calculate the root polynomial. That's what he has told over here. Till now, for shaded part, we were not calculating over here. See, such places are called forbidden. Arrangements with forbidden position. Forbidden positions for such objects. For that, to do the forbidden objects, we are going to use the concept of root polynomial. So for the board C, now this is again what we can apply the product rule, because this is one, I can take this as one section, this entire box as one section as C2, and this entire section I can take it as C1, because there is no row and no column below this, and no row here. Here also there is no rows and no column that is getting clashed. Okay, so I can take this as C1 and this as C2, this as C1 and this as C2. So what I can do is, for the board C made up with shaded square in the above figure, the root polynomial is, so for the board the root polynomial for the board C, this is the C, the root polynomial you have to calculate. Root polynomial, again product rule itself, root polynomial. For this root polynomial I have already solved in the example 1 problem of the this one. See here, same concept, 1 2 3 4 5 6 7 8 9 10 11. Already I have calculated using the product rule, so I'll not solve this problem again. You can refer, you have to write all these steps you have to write and solve till here until you get this particular equation. I'll not solve this again because it's already been solved in the example 1. I'll directly write this equation, r of c of x over there. R of c of x is equal to this equation I'll be writing over there. Okay, but you are supposed to solve taking this as C1, you have to calculate all this and find C1 of x. Taking this as C2, you have to calculate what is R1, R2, R3, and then you have to apply product formula. Then you have to apply the product formula. Is it clear? So this is how we are going to solve polynomial concept. So for the board, the root polynomial for this entire board, we'll get it from there itself. Remember students, you have to solve this boards. You have to solve these boards using the product formula. Refer example, I'll just write refer example 1 of this video. Refer example 1 to find this. So R of C of X will get directly as 1 plus 11x plus 1 plus 11x plus 40x square plus 56x cube plus 28x to the power 4 plus 4x to the power 5. Okay, so here 1 plus 11x plus 40x square plus 56x cube, 28x4, 4x5. So you can refer here and check same 1 plus 11x, 40x square, 56x cube, 28x4, 4x5. So you have to solve this entire problem and get this. I have just mentioned because I have already solved over there. Now from this entire equation you came to know that R1 is 11, R2 for this is 40, R3 is 56, R4 is 28 and R5 is 4. So this is regarding R1, R2, R3, R4, R5. So once you got these values, you have to use this particular formula. So I'll write it in a new page. Consequently the formula is the rule is n bar you have to calculate. So n bar is equal to S0 minus S1. S1 means it involves R1, right? S2 minus plus S2 minus S3. It involves R3. How many are there over here? R4 and R5. So again plus S4 minus S5. Okay, plus S4 and S1, S2 minus S5. So this is the formula we have to calculate. So you know that S0 is nothing but n factorial. So what is our n over here? S0 is n factorial. So what is n? N we have 5. Class teacher we have taken this as n. So n is 5. S0 is 5 factorial. That is nothing but 120. S1 formula, if you see S1 formula, n minus k factorial into rk. So n minus k factorial if it is sk, n minus k factorial into rk. So we need to find S1, right? So S1 is nothing but 5 minus 1 factorial into r1. So 5 minus 1 is nothing but 4 factorial into r1 value is 11. So this would result in 264, and S2 is 5 minus 2 factorial into R2, 5 minus 2 factorial into R2. So that would result in R2 value is 3 factorial into R2 value. So R2 value is 40, 3 factorial into 40. So that would result in 240, and S3 is 5 minus 3 factorial into R3. So that would result in 2 factorial into R3 value. R3 value is 56. So 56 2s it is 112. S4 is 5 minus 4 factorial into R4. So that would result in 28. 1 factorial into 28. So that would give me just 28, and S5 is 5 minus R5, 5 factorial into R5 value is 4. So 0 factorial is 1. So the answer is 4. So accordingly, the number of ways in which the work can be assigned is this n bar is equal to s0 minus s1 plus s2 minus s3 plus s4 minus s5. So this would give me s0 is 120 minus 264 plus 240 minus 112 plus 28 minus 4. This would result in 8. So this is the answer for this particular problem. So example 2 is nothing but an apple, a banana, a mango and an orange are to be distributed to 4 boys, B1, B2, B3. So you came to know in this question itself, apple, banana, mango and orange. I had explained you in the while explaining the forbidden positions. So this has to be distributed among 4 boys. So how many objects are there? Apple, banana, mango and orange, and there are B1, B2, B3, 4. So let us draw the table for this. So it is 4 cross 4. Okay, so this is 4 cross 4. So 1, 2, 3. 1, 2, 3. This is 4 cross 4. So here whatever the objects we are placing over here, so let it be apple, we'll take it as A, banana will take it as B, and mango will take it as M, orange will take it as O. And how many boys are there? 4 boys. So it is B1, B2, B3 and B4. B1, B2, B3 and B4. So the first part we have done. These objects I am distributed among 4. The boys B1 and B2 do not wish to have apple. Boys B1 and B2, that means these both, they do not wish to have apple. So this is a forbidden position. The boy B3 does not want banana or mango. Boy B3 does not want banana. He doesn't want banana or mango. Okay, B4 refuses orange. That means he doesn't want. So in how many ways the distribution can be made so that no boys is displayed? So for this shaded part we are going to find the Rook polynomial. Remember it, here it is bit because we are finding for the forbidden positions. So the situation can be described by the board. I'll write the solution. The situation can be described by the board shown in figure below. This figure, okay, I'll write figure below, shown in figure below, okay, in which the rows represents, just write down, in which the rows represents the apple, banana, mango and orange, and the columns represents the B1, B2, B3, B4 respectively. Also the shaded squares together represents the forbidden. Also the shaded squares together represents the forbidden places in the distribution. Forbidden places in the distribution. Now what we can do is, here we can apply product rule here also, because when you see over here, this row doesn't have any other boxes and this column doesn't have any on boxes. So this we can take it as C1. For this 2 boxes I can take separately, because again it doesn't have over here, and this also. This can be taken as C2 and this again separate can be taken as C3. So let us consider the board C. I'll just do it in the next page. So let us consider the board C consisting of shaded squares in the figure. Consisting of the shaded square in figure above. So C can be, so C is mutually, so C is mutually disjoint board. So C is mutually disjoint board C1, C2, C3 shown in below figure. You know that product rule is nothing but R of C1x is equal to into R of C2 of x or into R of C3 of x. So C1 is nothing but with two boxes. I'll just wait 1 second. This is C1, C2 is this, and C3 is just one box. So if you see here, these two boxes, this box and this box. Okay, so using Rook polynomial, that is product rule, R of C of x is, using product formula, R of C of x is R of C1 of x into R of C2 of x into R of C3 of x. So this would give me, so R of C1 of x, just find R of C1 of x, where in R of C1 of x, R1 in R of C1 of x, R1 is equal to 2. R1 is equal to 2, whereas R2 is 0. If you see, there is no combination, and R3 is also 0. So in R of C of R1 is 2. So the equation will be R of C1 comma x would be 1 plus 2x. So in R of C2 of x would be, in R of C2 of x, R1 will be 2 again, R1 will be 2, again R2 is 0. So R of C2 of x also will be 1 plus 2x. Okay, and in R of C3 of x, R1 is equal to 1. So R of C3 of x will be 1 plus x. So therefore R of C of x will be, equal to 1 plus 2x, again into 1 plus 2x, again into 1 plus x. So this would give me, if you just multiply, this would give me 1 plus 5x plus 8x square plus 4x cube. Okay, so this is the final equation, R of C of x. Now from this we came to know, from this, thus for C, R1 is equal to 5, R2 is equal to 8, R3 is equal to 4. Okay, so consequently formula n bar would be what? If you just check for the formula, here we have only R1, R2, R3. So consequently n bar will be S0 minus S1 plus S2 plus minus S3. So the formula will be just S0 minus S1 plus S2 minus S3. So calculate S0. S0 is n factorial. So n factorial is nothing but, what is n factorial? N factorial would be nothing but 4 factorial, because you have, check the board, you have 4 balls away. So it is 4 factorial, so that would result in 24, and S1 would be 4 minus 1 factorial into R1, so that would be 3 factorial into R1 is 5, 3 factorial into 5, so that would result 13, and S2 is 4 minus 2 factorial into R2 is 8, so it is 2 factorial into 8, so that would result in 16. S3 is 4 minus 3 factorial into R3 is 4. Okay, R3 is 4, so it is just 1 into 4, so that would result in 4. Therefore n bar is equal to S naught is nothing but 24 minus S1 30 plus 16 minus 4, so that is equal to 6. So this is the number of ways of distributing the fruits under the given constraint. So this is the, therefore this is the number of ways, this is the number of ways of distributing the fruits under the given condition, under the given constraint. So this is the concepts regarding different types of concept based on the root polynomial. Thank you.